Hi everybody, welcome to today's video. We're going to be talking about congruence. Alright, so congruence, if you see this little line, it means congruent. So if you see that when you're doing equations, that's what that means. So what does congruence actually mean though? It means same size, same shape. So if you look at these right over here, A, B, C, and D, E, F, they are the same size and the same shape. Is it same sides, same angles? Angles and sides need to be the same for these figures or shapes to be congruent. All right, so you got to have the sides and the angles. Those are 6 parts of a triangle, 3 sides and then 3 angles. You only need to know 3 parts of the triangle instead of all 6. So you don't need to know every single side and every single angle. The reason is because there are 5 ways or theorems to find congruence. So we're going to dive into what these are and exactly what theorems you'll need to know. So before we dive into that, let's talk about congruent versus similar. So there's a difference between the shapes being the same, similar to each other, and being congruent, the same size and same shape. So triangles that are similar are just going to be that. They're triangles with the same shape but are different sizes. If you have to make the shape bigger or smaller, it's only similar. If you have to rotate it or transform it in any other way, then that's most likely going to be congruent. If you don't remember what reflection, translation, and rotation are, go back and watch that video on transformations. But if you are dilating or reshaping, it means it's only going to be similar. All right, so the first theorem we got is SSS. That just means side, side, side. All 3 sides are similar for a triangle. The triangle is congruent if all the sides of the triangle are the same. You don't need to have any angles or know about any angles. So here we have the same sides, 3 and 3, 5 and 5, and then 6 and 6 right over here. So that shows that the triangle is congruent to the other triangle. And usually when you mark off different sides, you'll put like 1 dash. And then for the second side, you'll put 2 dashes. And then the third side, you'll put 3 dashes. That's what those mean, just in case. Next up, we got SAS, side, angle, side. So for triangles that we only know 2 sides and an angle. This one, the angle is kind of sandwiched in between the 2 sides. So you see we have a side, an angle, and a side. They're all kind of connected, just like the letters SAS. So SAS, SAS. That's how we're going to determine exactly what you'll need to figure out how to do that. All right, so if it is side, angle, side, the angle has to be in between those 2 sides. What about if it's the opposite? So angle, side, angle. That also works too. If you only have 2 angles and a side, the side is in between the 2 angles. So angle, side, angle. Angles match up on both sides, and then both angles here and the sides. So see in this shape, it just needs to be rotated, and then it can turn into this shape right over here. So definitely remember these. You can, if you are just doing a simple transformation of movement, that is fine. But if you're reshaping the figure, it's not going to work. Fourth, we got angle, angle side. So remember how I said the others were sandwiched in between? If it is not sandwiched in between, and if it's just the angle on the side, that is okay. You will still be able to figure out how to do it. All right. You'll still be able to figure out if it is congruent. The difference is that, like I said, it is not sandwiched in between the angles. So it's angle, angle, and then side. The side is on the outside, is not in between the angles. Finally, this one is a lot easier because it is only for right angles. It's hypotenuse leg, HL. It's only for the right triangle. So if you see this little box, remember this little box in the corner of a right triangle makes it a right triangle because that measures to 90 degrees. All right, this is every single time you see that little thing. So right triangle with an angle of 90 degrees. The hypotenuse is the longest side of the triangle. So right here where 9 is, that's the hypotenuse. And then the legs, it only has to be one leg. It doesn't matter because um, it can be flipped. So this is a leg and then this is a leg as well, but clearly these are equal. So you only need to have one leg to be equal with hypotenuse and leg. And that's how you'll know it's congruent. If you need help with triangles or right triangles, go ahead and watch the other video I've done on how to identify triangles and how to measure them up. Be careful though. Do not use AAA, angle, angle, angle. I know we had side, side, side be a way to determine congruence, but angle, angle, angle is not a good way to determine congruence because all the angles inside can be different, but on the outside, the sides are going to be all messed up. So you can have like 20, 40, and 38, whatever like the measurements are inside, it could equal to another triangle, but that doesn't mean the sides are going to be adding up. It just means how much the sides are like moving and stuff. All right, does that kind of make sense? So angles can be similar, but sides will still be different. So don't fall for that. Why do you even need these theorems? So these are mainly used for proofs, all right? So proofs are how you prove that certain figures are congruent to one another. Use this as a stepping stone to help with writing proofs. If you need help with writing proofs, we will get there. Um, I don't know if they are on the high set, but I'm going to prep you for it anyways. So um, remember your theorems: angle, angle, side, side, angle, side, 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 angle, angle, side, and a hypotenuse leg. Those are your 5 theorems. That's how you prove triangles are congruent with one another, all right? These are going to be your foundations for writing these proofs, all right? You're just proving it would have a big figure and show, all right, how are these two triangles congruent? Oh, side, angle, angle, side, whatever it is. So that's just the way that's going to work. So let's do a quick learning check, all right? In order to earn credit, as always, for these videos, please determine whether or not the triangles are congruent, and if so, state the theorem that proves that they are. So you're doing little mini proofs, all right? Proofs are a lot longer, and they can be more of a headache. So we're just going to start small. I want you to just look at these triangles, find the theorem to prove that these are in fact congruent or if they aren't congruent. So go ahead and pause the video, write them out, submit these and your notes for credit for this video. And if you have any questions, let me know. Thank you so much and have a great rest of your day.